Today I'm saying goodbye to my OneFinity CNC and welcoming the new Elite Foreman to my shop. In today's video, I'm going to be covering how I built the table for the CNC as well as my new logo backdrop, and then I'll be doing a brief unboxing and overview of some of the new features that are part of this machine. Now what I won't be covering today is the new Spoilboard system that I've got for this machine, because that'll have its own dedicated video in about a week or two. All right, let's get building. As I was disassembling the enclosure around the CNC, I decided that I wanted to save this black logo that had been on the back of my enclosure. And so I fired my CNC up for one last time to do a cutout of the logo, and I'll find a way to incorporate that into the backdrop for this new Elite Foreman that I'm about to set up. Now, for those who have been watching my channel for a long time, you'll know that the first short I ever published on this channel was actually creating a logo using this OneFinity CNC. So it's only fitting that the last project that I do with this CNC is also a logo. So just like that, the CNC was gone. Let's take a moment of silence. All right, now let's shift the focus to the design of the new table that's going to fit in this space. Anytime I'm going to do a big project like this, I always map it out in SketchUp first, just so I can see how it's going to fit in the space and make sure that clearances and walkways are not obstructed. Now, I'll be using a similar 4x4 construction to my previous design, but obviously scaling it up to account for the larger footprint of the Elite Foreman. I'll also be matching the height of the CNC table to my outfeed table for my table saw, so that if I ever want to put a larger slab in the CNC, either to do some flattening on one half and then flip it around the other way and flatten the other half, or maybe I want to do some engraving or some insets using the CNC, I've got that ability to straddle a large piece across from my CNC table to my outfeed table. With the design finalized, I take my cut list and get to work. To assemble the base, I'm going to be using a combination of some dominoes and some wood glue to keep all the pieces together. The dominoes were a big help in having all these different pieces of the base come together. I normally work alone, so having some assistance with the alignment coming from the dominoes is a big help, particularly as you're trying to get some of these complex glue-ups to come together just right in a limited time window. While this glue was drying, I decided to turn my attention to the logo backdrop that's going to be the focal point of a lot of my CNC filming in future videos. And I've got the perfect batch of walnut picked out of my shop. It's some rough cut walnut that I've been holding on to for a while. That's not quite nice enough to be used in furniture, but it's great for tongue and groove siding, which is going to be the backdrop for this particular logo setup. So after cutting everything to length, I began to go to work making these 5-inch tongue and groove boards. To create the tongue and groove pattern, I'll be using a pair of white side bits. I'll run one edge of the board against the A bit and then the opposite edge of the board using the B bit. The combination of these two will create the tongue and groove pattern that we'll use in this backdrop. I used some furring strips to create some separation between my drywall and the tongue and groove panels, and once the first board went on, the rest went together like clockwork. I used some beautiful curly maple to frame in the tongue and groove backing, and once that was complete, I used a French cleat holder to hold my new logo to serve as the centerpiece for this backdrop. The last step to wrap up this part of the project was to apply some finish, and I decided to use some Osmo clear satin to make the walnut pop and bring out the curl in the maple. Now that the table base has had time to dry, I turned my attention to creating the tabletop that is going to support the larger footprint of the CNC. I used my track saw to break down 2 full sheets of plywood to create the 64-inch by 67-inch dimensions for this tabletop. I'll be using a domino joiner to connect these 2 different pieces to make one seamless tabletop for the CNC. With the table built, let's get to the unboxing. On the right side, you can see the longer boxes that have each of the 3 axes plus the additional stiffy that was an add-on. In the larger box down the bottom, we've got all the additional components, including the Masso controller and the power unit. And then this top box here, you see the spindle kit from Foreman CNC. As I was taking everything out of the box, I noticed that everything was very well packaged and preserved for transit. There was also really good labeling put on all the connector cables and the power cords to ease the installation process as well. The assembly of this Elite Foreman is very similar to the prior versions of the OneFinity machine, so I'm not going to spend too much time talking about the installation, but instead I'm going to focus on some of the differences between this Elite Foreman and my old machine. The first being the monitor mount that you see here is actually meant for the 15-inch Masso screen, which is also the controller for the CNC. Now that's not to be confused with the black power box, which it kind of looks like the old OneFinity controller, but it's just for the power distribution. The screen is actually the controller for this particular unit. Now, as you can see from the unboxing, this Masso controller is pretty substantial. So the screen size is 15 inches, but it's about 1.5 inches, maybe 2 inches thick. And you can see the emergency stop button is integrated as a part of this screen. So this is going to be your visual interface as well as the controller that runs your entire CNC. Now later in the video, I'll walk through this controller whenever it's powered up. But first, let me talk about the VFD Spindle Kit that I got from Foreman CNC. So when you buy these from Daniel, everything is plug and play and ready to go. So I got the 1.5 kilowatt, 110 volt version of this spindle kit, and it comes with everything you see here. I'm holding the VFD right now, and I'm going to do a detailed walkthrough in just a second. But I did opt to get the 80 millimeter spindle. Now, this thing is quite substantial relative to the Makita router that I've been using. It's very heavy, and it comes with a number of different collets for different size bits that you may want to use. Now, one of the decisions you have to make as you're buying your machine is if you want your spindle mount to come sized for a 65 millimeter spindle, which is what the Makita router is, or if you want the larger 80 millimeter version, which is what I'm using here. And installation was pretty quick. There was just 2 hex bolts that had to be tightened on the spindle mount, and then the power connects through a threaded coupling at the top of the spindle, and then the cable is run back to the VFD through the drag chains. So I thought it might be helpful to do a quick overview of how the spindle and the VFD is set up. So here's the VFD hanging on the side of the table, and you've got the main power line coming into here, and you've got an on-off switch for the power button. Then you've got this little threaded coupler connecting that actually feeds power back from the VFD, and it goes all the way up to the spindle. and it's routed here within this cable chain, so where you can actually get power to the spindle reliably, and then these drag chains hold all the cabling for your X and Y axes, as well as the power cable that goes to the spindle. The other advantage of a spindle as opposed to a router is you've got this line here, this PWM line that feeds back all the way up here to your controller on your Elite Masso. And that Masso controller will actually read the RPMs that you've specified within your G-code. So whenever this is in automatic mode, which it is right now, and you press run on your Masso controller, the spindle will automatically vary the frequency of the power going to your spindle to match the RPM that you've specified within your G-code, which is great because it takes the guesswork out of having to estimate what RPM your router is putting out, and you can get an accurate representation of what it is coming through here. Now, if you wanted to run your VFD in manual mode, you can do that as well. So then that means that there's not a signal going to and from the controller from here. Instead, you would just press run here, and then you could vary the RPMs going to your spindle. So right now we've got about 10,500 RPM. You can see that the bit is actually spinning at about 10,500 RPM. Now let's take a look at the spindle from up here. This is the main power connector that comes in on the top, and it's got another one of those threaded coupling connectors at the top. And this is the 1.5 kilowatt spindle kit from Foreman CNC. This particular version is it's air cooled, and it's the 110 volt version. They do make a 2.2 kilowatt version that runs off of 220. I did have a spare 220 circuit available, but I didn't think I needed anything more powerful than what I have right in front of me. One of the nicer things about having this 80 millimeter spindle is it's got multiple collets. So this is an ER20 collet, and the spindle kit from Foreman CNC comes with 3 different collets. One for 1/8 inch, one for 1/4 inch, which I'm using right now, and one for a 1/2 inch. So I'm able to use 1/2 inch bits with this particular kit. One last thing I want to cover is some of the cable management that I've done to try to keep this as clean as possible. So I've drilled some holes in the table, and I actually have notches that were cut out as I was assembling the table so that all the cabling can be run neatly underneath the table. And you can see I've installed some drawer slides because there's going to be some drawer inserts here that have a customized inset for all my CNC accessories and tools. So that's still another project that's still to come. And under here is kind of where all the cable management is happening. So I've used a series of these holders for all the major cables. I've used a number of zip ties. And then underneath here, I've actually installed kind of a false ceiling right here where I've got some of my cables tucked away and zip tied underneath here. So the power control unit is right here. Let me slip around. So this is the underside of the power unit. Here is where the power is coming in, and then all those cables around the front feed each of the axes, and also feeds the CNC control unit up there. And then up here, it's kind of the underside of where I've got all my cables. Now, I've got 2 different power strips that are supporting the CNC. I've got a dedicated power unit for the spindle, and on this side, I've got a dedicated power unit that is controlling the actual CNC. So those are on 2 separate breakers so that there's no feedback interference between the 2 different systems. I learned that the hard way on my last CNC, where whenever the router would get going, sometimes it would provide some feedback to the CNC controller, and I just didn't really like the screen would flicker and provide that feedback. So that one's been rectified for this particular design. But yeah, more to come. This is the Spoilboard system that I'm working on. That's got a combination of T-track, dog holes, and then these threaded inserts. And I'll be doing a dedicated video on how I built this and how I'm using it with this new CNC. Actually, while I'm here, I'm just going to show you how these are being used. So on the bottom side, we've got some 3/4 inch dog holes, and these fit right into here. This can actuate back and forth, and this clamp right here kind of cinches that workpiece closed. So now that is clamped in place. So a combination of dog holes, threaded inserts, and T-track are going to give this Spoilboard system a lot of flexibility. And what I'm in the process of doing now is building these 24 inch by 24 inch sacrificial boards that are going to go on top of this, because I don't want to carve directly into this if I'm going to be cutting through material. So I'm going to be having some sacrificial boards that are going to be a lot more easy to replicate and don't jeopardize some of the threaded inserts that I've got installed in this particular Spoilboard system. Now let me spend some time walking through this Masso controller. Ooh, that's satisfying. So the Masso controller has 6 different tabs up at the top of the control unit. Setup, generally all this stuff is related to the machine settings. You can actually, if you go under homing, you can change the homing feed rate. So if you want it to home quicker, it can do that as well. But I didn't touch many of the settings that are in here. All that stuff is pretty much good to go. The program, so if you have G-code, so if I come over here to load file, which is the end, and I want to load the 24 by 24 inch dog holes, it'll actually load this file onto this workspace. And if I come back over here to program, now you've got all your G-code loaded. If you wanted to actually run this, you would put spindle, and then you could press start and it would start to go. So again, that G-code is going to be driving the RPM of your spindle based on what you've programmed it into. Under jogging and probing, we've got the ability to actually move the spindle or the axes back and forth. This feed rate here, you've got a slider bar, so if you wanted to jog quicker, you can do that too. Now, one drawback to the Masso is you cannot pair it with a remote control like you could the prior unit, which is a little bit of a bummer for me. It makes you kind of come back to the control unit more so than I'm used to. So that's something that it's going to take a little bit of an adjustment period. Now, as you're jogging, you can toggle between the step mode, so it'll only go in the increments that you specified here. And if you're in continuous mode, you've got the slider bar that can go back and forth. Tools and offsets, you've got a number of different tools that you've got pre-programmed in here, and if you've got some offsets that you want to customize, you can actually program it right in here. This F5 tab, conversational, I haven't used this yet, so I'm not really sure exactly what that does. And then load file, this is where you've got, it's hard to tell, but at the bottom of this control unit, let me pan down a little bit, there's a little entrance for a USB tab or USB stick right here. And these are all of the different files that you've got on that USB stick. Now you can send files to the USB stick because the controller doesn't have any onboard memory, so you've got to have the USB stick plugged in order for it to store those files somewhere. But the online interface is not quite as user-friendly as the prior OneFinity control unit, where you had a web-based interface and you could send files and interact with the machine remotely. The Masso software is pretty basic. It allows you to send files to and from, but it doesn't have that interactive software. So like I can't see this on my computer screen. I also don't have access to a camera to look at what's being done on the CNC like the prior interface did. So that's a little bit of a drawback as well. The touchscreen is very responsive. Whenever I tab around, it's very quick. So first impressions, overall, I like it. There's going to be a little bit of a learning curve, just understanding all the features, but I'm excited to get to know this machine a little bit more. There's a few more features of this particular unit that I want to talk about since I'm upgrading from a 32 inch by 32 inch WoodWorker CNC. So I had a much smaller cutting area than this Elite Foreman, which is a 48 inch by 48 inch cuttable area. And the rails on the old unit were 35 millimeters in diameter. This right here has 50 millimeter diameter rails. And for all the engineers out there, rigidity increases to the 4th power with diameter. So that additional rigidity helps preserve accuracy for some of your larger cuts, particularly since this spans over a larger area. Another key difference between the two different CNCs is the use of the closed loop motor for this Elite unit. Now, the prior version used an open loop motor, which means that whenever there was a signal sent from the control to the motor, it was a one-way signal. So there was no feedback mechanism to understand if that motor actually made the movements that was prescribed by the controller. So the fact that this is a closed loop motor, and that's where some of these additional wirings come in, sends that signal back to the controller. So if there's an interruption in power, or you need to stop the car for whatever reason, it can resume where it knows that it left off in the particular section of the G code, because it had that feedback mechanism as part of the execution of the work. The second major difference is how the machine actually homes. So in the prior version, the machine would home by bumping up the rail against the edge of the movable area, and the motors would see an increase in resistance, and that signal would go back to the controller to say, I have now reached the end of my motion. This must be the end of the x-axis or the end of the y-axis. In this Elite version, there's actually a metal receptor here that breaks the plane of an infrared sensor. So as this breaks the plane, there is a optical recognition that this particular homing has taken place. So whenever it happens, it now registers as this is being homed. So all the axes have this particular optical sensor to recognize where home is. Once the controller recognizes where the home position is for each of the 3 axes, it'll do a soft stop whenever it approaches that particular end of the movable area. So there would be times whenever I'd be operating my old OneFinity, and sometimes the home would be off by a couple of tenths of an inch, and then there would actually be an impact on the rails that would kind of jar closed or come to an abrupt stop. This particular system does not have that same issue. All right, I'm going to go ahead and end this video here. Thank you so much for watching. Remember to stay tuned for the Spoilboard video that's going to be coming out shortly, and make sure you subscribe because I'm going to put out a whole lot more CNC content. I'll see you on the next one.